Alright, so maybe we're back, hopefully. Sorry about that issue. It was a network outage here, so it unfortunately meant that I lost my connection, and so now we have to kind of restart a little bit. So hopefully it will all work out fine from now on. So let's go back to where we were. So I was trying to explain the data structure that we'll be using for this problem. So I have this vertex record that we will be using to store the individual vertices of the problem, and then the neighbors are the connections, or we can actually do connections. That's better name, connections, because those are wires, so it's wired connections between the edges. So now what we need to do is to create some kind of dictionary of vertices, exactly, and we will have to read the input. So input is gonna be file read all lines input txt. So I will read all the input, and now let's do a for each line in input. We'll read the line, but split by something else. Split line split by, there is colon, and then we will have the name, which is this one, and then we'll have the connections, and that's not by this, but by space, and I will split it and remove the empty entries. So this will give us the connections to that vertex, and then we will have to make sure that we connect them all. So for each connection in connections, I will make sure first that the vertex is created. So if it doesn't exist in the list yet, vertex, oh, I have to close this. So if it's not in the list yet, I will add it. And for each of those connections, I will also add the connection. So we add the connection, and then we add bidirectional connection to that specific vertex. So both have the connection between each other. So this is the way we do it. All right, so this should be reading the input file. And now what we will have to do is, we'll always start with a node, a vertex. So let's start with current will be vertices values first, doesn't really matter. And we will be doing something 3 times. So we'll be doing this 3 times, and we will be going from that current vertex and searching for the farthest vertex from that current vertex. So find farthest from current, and we will, as a return of that, we need to know which vertex is the farthest, and we need to know which connections we took to get there, I think, yeah? So let's just think through that. We need to, so it's gonna be the farthest and path, so that will be like the return, and we'll have vertex farthest, and it's gonna, then we have a path like this, farthest from source. So I'm not sure what this is, but let's see what it generated. sometimes it's useful, at least parts of it. So we have okay, so we have list of visited. We'll be doing breadth first search because we need to kind of do wave from the source to mark the ones that are first in distance and so on. So we'll have also distances, and yeah, so that's weird. That should definitely don't need this thing. And I would say we would like to have something like vertex or dictionary previous. Yeah, so we are getting, or not really this way, maybe. Yeah, yes, that's fine. So we need to, for a given vertex, we need to know where we were before we got there. So we'll need distances. We need something to mark the farthest so far, and we need to figure out. Yeah, we'll be pushing not this. That's ugly. Let's just push the vertex that we are processing, and we need to keep track of what vertices we already visited. So enqueue source, and when we dequeue the source, the vertex, like current, we add it to visited. Yeah, they are actually there on YouTube. You can find them on my profile. There is actually a playlist specifically with all the Advent of Code videos. Let's see. Should be. Where do I have it? There's a playlist on my profile which is called Advent of Code 2023, and then you will find all of them neatly arranged one after another. So that should be all you need. Alright, so then let's continue here. We have the visited ones contains current, then we continue, otherwise we add it, and then we'll be going through all the possible connections to add. And well, I also have to set the distance. So distance, right. And previous for sources now, and distance is source is equal to 0. Right, and this is actually nullable. So let's mark it as that. Okay, so then we go through the connections. So starting there, we'll go and if not visited, if you already visited that connection, then we don't have to process it anymore. And if, well, distances doesn't contain connection. Yeah, basically it's the same thing, but we can do it without this. Yeah. So if we increase the distance, we set the previous to current, and we also enqueue the connection. And finally, what I want to do here, if it's this farthest node so far, we set it as the farthest connection. So when we finish this, we should be able to reconstruct that path. So we'll take the link of, we'll create a list, and I will be adding the individual vertices. So while we don't get to null, we'll be adding the previous node on that path until we construct it all, and then finally return it. It's gonna be an array, right? So then that should be it. And what is it complaining here about? It's about... Alright, I named the same thing, so... start vertex Right, that should be fine. Farthest vertex, and what is complaining now about? All right, it's we need to do a var here, and this is gonna be declared in the scope, right? Why? What am I missing here? That should be fine, all right? I don't see a problem here. Where do we see that current? Oh, I see here. Oh, okay. All right. Path vertex. All right. So let's see. Like this. That should be okay. All right. Now that we do have this, now we do. We have to remove the edges between remove the connections between the vertices on the path. So for length, we'll start on the second node. So our from will be this, 2 will be this, and we will be removing the connection between them so that it's no longer there, and we know that somewhere on that path was our bridge between the components. So when we do this 3 times, we should have removed the 3 bridges that are between components, and as long as we didn't disconnect some vertex completely, which hopefully didn't happen, because it's very saturated graph with many edges, so they should have multiple connections. We should hopefully be able to see the right. We have 2 components that are completely separate. And I will set the start vertex to be the farthest vertex again, so we can process it 3 times in a row. So when this is done, we have 2 components, hopefully. And now we need to just figure out the size of one of them. So select the component representative. It will be, for example, star vertex, whatever, doesn't really matter. And then we will find, we'll have to component size. Calculate component size with that component representative. And then when we finalize the calculation, we need to multiply that with vertices count minus component size, because we need to calculate, we multiply it with the size of the other component that we have. So now the only thing that remains is to implement this method, which will be calculating the size of the component. Let's move it down there so it's neater. And figure this out. Okay, so what we can do there very easily is basically just do either BFS or DFS, that first search, through that graph to find all the components. So our visited, all visited ones, and we enqueue the component representative and add it to the visited, and while queue count greater than 0, we will dequeue, and all the connections we will, if it's visited, we continue, and if not, we will add it to visited and enqueue, so it gets processed later. So ultimately we should be done and return visited count. And that should be the size of our component. So hopefully, if everything went smoothly here, we might have a solution there. So let's see what happens if I run it. -6, that's definitely not right. So let's see what's happening there. -6, that's weird. Let's see. Let's see, this is, okay, I have this. So let's first run it here to see if the reading in works fine. It seems okay. Connections seems fine at least. So that's okay. Now after this, okay, so there's something wrong there. Source is null. How did that happen? Call stack. Okay. No. How did that happen? Coming from null vertex. Okay, that's interesting. So something is happening incorrectly there. The component size is 701. The total number of components is this seems. Oh, that's not the right one. I wanted to multiply. I was subtracting. And okay, so that was a not smart mistake. And we have this number. So let's see if that is correct or not. Let's see what happens. And it is correct, so we have solved this problem, and let's continue part 2. And yeah, we are on 49 stars, but we need power of 50 stars. Yeah. Okay. So that's fine. We can restart the system and push the big red button. And we are done. So we supplied all the 50 stars and restarted global snow production, which makes Christmas finally happen in June of 2024. And it's finally finished. So that's great. I'm very happy that it finally all came together, even though it took me quite a while. But it's done now. So yeah, that's cool. It's a good feeling to have it. What is that? Oh, those underlines are Easter eggs, apparently. So yeah, we're done. We're done. That's pretty cool. So I can officially mark Advent of Code 2023 as completed. It was a long run, but finally we are here. And what I can actually do now as well, maybe, is to try to ask ChatGPT if it can also solve the last day or not. Because we already did it for all the other days, so it would be nice to see if it's capable of such a feat. But I am not really confident that it will be able to solve this, because it's a complex problem and it's kind of probabilistic unless you do it this hacky way, which kind of requires you to understand the input structure. So it's maybe gonna be too tricky for ChatGPT to solve. So let's see what happens. I will copy the problem description and put it here. Let's see what happens. Okay, so it's doing the right thing, doing the components and representing the graph and finding the critical edges. But because those edges are free of them, it might be more complicated than that. So let's see what happens. Oh, it didn't solve it. It just stopped. Not sure why. Usually it just executes against the input, so let's let it do its thing. Okay, so it's executing and it's not finishing apparently. Some kind of timeout is gonna happen. So usually when there is a infinite loop, when there is a timeout in ChatGPT's execution, it's usually the infinite loop somewhere happening. So I'm guessing here they are doing some kind of infinite loop, or the processing is just not as fast as it would like to because the input is kind of big, so it might not be finishing in time. Right, so far nothing. Yeah, so it froze in it timed out inside of the vial. So apparently, so it's now gonna try a heuristic approach to find critical edges. Instead of finding the correct solution, it will try to find the best possible solution that's possible in that time and figure out the solution this way. We'll see if that works. And again, it's doing the same thing as it did last time, where it outputs the code for the solution and then executes it separately, which is kind of odd. That wasn't happening before. Oh, and we have a 0 here. So what I have to give it to the author of Advent of Code, that most of the problems this year were barely solvable or even impossible to solve by ChatGPT as it is right now. It wasn't able to solve those problems. Often it was because the problem required understanding of the input's format or of some particular quality of that input that nudged you in one direction, one specific way of solving it, which would not be a universal solution, but applied to the specific input. So that's one reason why ChatGPT failed often. And the second reason is that the input format was often so specific and complex that ChatGPT just wasn't able to understand how to read it correctly, and it often failed to see some small nuance that just made the whole input incorrect when it read it itself. So it's usually, oh, let's run this, but it didn't run it actually. Interesting. Continue. So ChatGPT usually just gave up then, and it tried several times to fix the input reading, and it failed because it wasn't parsing it correctly. It was misunderstanding some condition or some specific part of the input or some way it was formatted, and it just wasn't able to solve things. So I think the input and input parsing and input understanding were the main hurdles that ChatGPT had for most of the advent of code problems, and we will see if that improves with some future versions of ChatGPT. But at least for now, it's not definitely replacing our jobs, because when it finally arrived to the right solution of many of the problems, it was after several nudges from me to steer it in the right direction or tell it what the problem was. And that is not something you can do if you want to rely just on AI, because you need to have someone steering the wheel and telling AI what to do or correcting its approach. So at least for now, most of the problems of advent of code were beyond ChatGPT's reach. So as well as this day 25, it just doesn't give me the solution so far, and it's just giving zeros, which is a common occurrence among the advent of code problems, that result was often 0, and sometimes ChatGPT even thought that 0 was the right solution, which definitely wasn't. So, yeah. Anyway, I think we're done here. So thank you very much for joining this short Advent of Code session, where we finally finished Advent of Code 2023. I will be making more videos with programming puzzles and even specific tutorials or .NET for .NET developers. Especially, I will be doing some interesting videos. So if you are a .NET developer or just a developer who wants to learn problem solving or improve in problem solving, subscribe to my channel, because there will be more coming. And of course, when December comes, I will be doing this whole thing again. So I'm already looking forward, because it's just 5 months to go for another Advent of Code. Yeah, so thank you again. Have a great day. Happy coding, and I will see you in the next live coding session. Bye bye.